During the last class, we were discussing about the for loop, the different types of for loop, actually different methods in which the for loop can be employed, and the complex statements by which a for loop can be used. That was we discussing in the previous class. And in today's session, what we will discuss is about the while loop as well as the do while loop. So this is in the case of for loop, we have to initialize the variable first, then we have to give the condition. The condition checking is to be given, then the increment or decrement is also to be given. So these three conditions have to be given in the case of a for loop. That is to be initialized, or that is to be given inside the for loop itself, inside the brackets, inside the brackets of the for loop itself. But in the case of while loop, only the condition is to be given inside the brackets. And in the case of for loop, the number of times that particular loop is repeating, or those statements are repeated, that is fixed. That can be fixed while formulating the for loop itself. That is, we can control the number of times it is being executed. But in the case of while loop, we can control it. That is one way. And in another way, if we doesn't know how many times, if a particular set of code or a particular block of code is to be executed, that the number of times it is to be executed is unknown to us in the beginning. In that case, we can use the while loop. But the for loop can be used only when we know that how many times this particular block of code is to be executed. So let us see what is this while and do while loops. So while loop, it also executes a block of statements as long as a specified condition is true. That is, we give a specific condition, and until that particular condition is true, this particular statements, or the statements that is given inside the while loop, is executed. And once the condition becomes false, then it goes to the next statement. Then a common way in which the while loop is executed, or it is being given inside a C program, is like this: while, then within brackets we have to give the condition. The condition can be any logical condition, that is whether any condition or any expression that will be evaluated to a true or false condition, or a zero or non-zero condition, that can be used inside the while loop. Then the statements are the lines of codes, lines of C programming codes that is to be executed until this particular condition is true. Once this condition becomes false, the loop terminates and it goes to the next statement. This is how a while loop works. So the condition may be any valid C expression. The statements may be either a single or a compound, that is a block of code statement. So the statement, this can be only a single line of code. If there is only a single line of code, no need to insert it inside the double braces or the curly braces. But if there are more than one statement, then it is to be inserted inside the curly braces. So if multiple lines of codes are present, it is to be inserted inside curly braces. Then when a while loop is encountered, the following events are occurred. The first, the condition is evaluated. When a while statement comes in a program, first what the program does is it evaluates this particular while condition. This particular condition is evaluated. Then if the condition is evaluated to zero, that is, it is evaluated to false. Zero corresponds to false, and if the condition is evaluating to zero or false, then the while loop is terminated and the execution is passed to the next statement. So this statement will be executed. But if the condition evaluates to true, that is, it is a non-zero value. If the condition is a non-zero value, then the C statement is executed. So the execution then returns to step number 1 and the condition becomes false. So this once this particular statement is executed, then again the control goes to this statement, the first statement. That is, it evaluates the condition. If the statement becomes false, then it goes to the next statement. So this is how the while condition, while loop is executed. And the flow chart for a while loop is given here. That is, we start, the starting can be anything. So then we evaluate the condition. If the condition is true, it goes in this direction. So this is T. T means true. So it goes to this condition, execute the statements, then the control is passed back to the evaluation condition. And if the condition is false, if the condition is evaluated to false, it goes to the stop. So stop or the next statement, whatever is it. This is only the case of while loop. So the same task, the while loop, most of the while loops can be replaced with a for loop. Actually, not all the while loop cannot be replaced with a for loop. The for loop can be replaced with a while loop. Any for loop can be replaced with a while loop. That is possible, but all the while loops cannot be replaced with a for loop. As I said earlier, in the case of for loop, the number of times, the code is to be repeated. Times of repetition is fixed. That is, it is to be fixed initially itself. But in the case of while, this can vary. The the number of times of the repetition is not fixed. It can vary. So vary in the sense that is it is evaluating a specific condition. Until that particular condition is false, this will get repeated. So if we give a condition in such a way that we doesn't know how many times it is to be repeated, so in that case while loop is to be used. Suppose a condition, let us check a condition like something like this. Say we have an integer n is there, and we want to find out how many times this integer can be divided with 2. Say if this value is 100, if n is 100, we can divide 100 with 2. First time it is 50, then the next time it is 25, and further we cannot divide it with 2 completely. That is, some remainder will come up. So in programs involving this type of situations, that is how many times it can be divided with 2, etc. So in that case, instead of for loop, we check for, we use with the while loop, because we doesn't know how many times this particular number will be, or we will be able to divide this particular number using 2. Suppose if this number is 100, it is 2 times, that we know. But if that particular number is 1000, in that case it is the first division gives you 500, then 250, then it gives you 125. So that is here it is 3 times, here it is only 2 times. Sorry. So in that case, in this type of situations, that is, we doesn't know how many times this particular operation is to be executed, but we know that only the thing that a specific condition is to be satisfied. So in this case, in the example set, the condition is that the remainder while dividing with 2 is 0. So that is possible in the first case. When n is 100, it is only 2 times. When n is 1000, it is 3 times. So in that case, initially we doesn't know how many times it is to be divided. So in that case, you have to go for the while loop. But this type of while loop cannot be replaced with a for loop. But all the for loops can be replaced with a while loop. So another difference between the for loop as well as the while loop is that while statement does not contain an initialization section. The program must explicitly initialize any variables beforehand. That is, in the case of while, only the condition checking is done inside this parenthesis. But in the case of for loop, see, the initialization is there, the condition is there, then the increment is also there. But in the case of while loop, the increment or decrement is there. So but in the case of while loop, only the condition is there. So the initialization is to be explicitly given, as well as the increment or the decrement. That also is to be given explicitly. So as conclusion, while statement is essentially a for statement without initialization and increment components. So that is something like this. So for, then semicolon, condition, semicolon. So if this is the for loop, then this can be replaced with a while condition. This can be replaced completely with a while condition, because inside the while condition, the variable is to be initialized somewhere else. Since here it is blank, the variable is to be initialized somewhere else before the for loop. And here this is also blank, so the increment or decrement is done somewhere else. So here also, in the case of while also, the increment as well as this decrement is to be done somewhere else. So the syntax comparison between for and while is given. So now, before moving on to our do while loop, let us see an example of this while loop. So here is an example, a simple while loop example. So into main void, we start with hash include stdio.h, then into main void, then we define a variable encalculate as 1. So we initialize that encalculate, the variable encalculate as integer, and it is initialized as 1. We define encalculate as integer and then initialize it as 1. Then while encalculate is less than or equal to 12. So this is the situation, this is the condition. So the initialization is done here. The initialization is done here. The condition checking is done here. While encalculate is less than or equal to 12, print %d encalculate. So if encalculate is less than 12 or less than or equal to 12, it will print. The program will print or display the value of encalculate. So the encalculate will be displayed here. Then here is the increment by 1. So encalculate equal to encalculate plus 1. So that is the condition. So encalculate is incremented by 1. So this is a simple while loop initialization, while loop implementation. So see, 1, 2, 3 up to 12 are printed here or displayed here. So that is what this particular program does. The encalculate is initialized as 1. Then it is checking whether encalculate is less than or equal to 12. If it is less than or equal to 12, then it has to print the value of encalculate. Then once it is printed, once it is displayed, it has to increment this encalculate with 1. So that is encalculate is incremented by 1. So this is a simple way of incorporating or implementing a while loop. Now let's see another while condition, that is a nested while. A nested while is a while loop inside another while loop. So these loops, these for loops as well as while loops can be put in any order. That is, while loop can be put inside the for loop, or for loop can be put inside the while loop. And we have seen that for loop can be put inside another for loop, as well as while loop can be put in another while loop, or while loop can be put inside another for loop. So that all those combinations is possible. The only thing is that we have to express it correctly, programmatically correct. It should be programmatically correct. So that is it. So in this case, in this particular nested while loop, while a is less than or equal to 5. So the first condition is a is less than or equal to 5. Here we have declared a and b as integers, and both are initialized as 1. So while a is less than or equal to 5, we take it as b equal to 1. Initially b take it as 1. Then while b is less than or equal to 5, we are checking whether b is less than or equal to 5. And inside this particular condition, we print the value of b. The value of b is printed. Then b is incremented by 1. Then once this particular loop is over, we print a new line character. We display a new line character, and then a is incremented by 1. So how this particular program will be executed? Let's see how it is going to be executed. See, this is the output of this program. Why this is printing 1, 2, 3, 4, 5, etc. Till 5 times it is being printed, because while a is less than or equal to 5, so a is initialized as 1, so initially a is 1, so a is less than or equal to 5, so that condition is true. So let us examine it or write it down. See, here initially a equal to 1, a equal to 1, so this condition is true. A is less than or equal to 5, that particular condition is true. Then b is set as 1, b is here b is equal to 1 initially. Then while b is less than or equal to 5, okay, b is less than or equal to 5, b is less than or equal to 5, then what it does is printf %d b. So b is printed, that is here the 1 is printed here. Then b is incremented, so b becomes 2. Now b is 2. Then the control goes back to here. While b is less than or equal to 5, b is still less than or equal to 5. So this b is printed. So that is this 2. Then b is incremented by 1. So b becomes 3. Now b is 3. So while b is less than or equal to 5. So b is less than or equal to 5. B is less than 5. 3 is less than 5. So then 3 is printed. 3 is printed here. Then b is incremented by 1. So b becomes 4. Then again, it goes back to this condition. B is less than 5. So 4 is printed here. Then again, it is incremented. B is incremented. So b becomes 5. In all these cases, a is equal to 1. Still a is equal to 1. So b is now 5. B is less than or equal to 5. So b is equal to 5. So again, b is printed. That is 5 is printed here. Then what happens is b becomes 6. So b, when b becomes 6, what happens is b is not less than or equal to 5. So the b is greater than 5. So this condition, this particular condition becomes false. This condition becomes false. So the control goes to this, sorry, not this. The control goes to this, moves to this particular statement. So printf /n is the new line character. So it prints a new line character, or it moves on to the next line. Then a is incremented by 1. So a is now a equal to 2. Initially a was 1. So once this a is becomes 2, the control is passed back to this while condition. The condition checking here, it is passed to here. A is less than or equal to 5. Yes, a is 2. So a is less than or equal to 5. Then again b is set to 1. B was 6, but now once this particular statement is coming up, b is set to 1. Then these statements are executed again, like 1, 2, 3, 4, 5. Then another new line character. A is incremented by 1, so a becomes 3. So when a is 3, this line now for numbers will be printed. Likewise, it goes to 5 times. So that is why here are 5 different lines of codes with 1 to 5. I mean lines of output, that is with 1 to 5 with in all these lines. So this is the condition with the nested while loop. That is one while loop, inside a while loop, another while loop is coming up. Now let's come back to our presentation. So the next is the do while loop. So in the case of do while loop, the condition checking is given at the last. The condition checking is given at the last. In the case of for loop as well as in the case of while loop, the condition checking was given initially. That is, first the condition is checked, then the block of code is executed. But in the case of do while loop, first a block of code is executed, then the specific condition is given, then the condition is checked. So In the do while loop, executes a block of statements as long as a specified condition is true at least once. That is, this particular block of code is executed at least once. Even if the condition is false, if the this do while loop will execute the condition, the statements at least once. But in the case of the while loop as well as the for loop, if the condition is false, it won't execute it anymore. That is, the condition won't be executed. If the condition is false initially, the code of the block of codes will not be executed. But in the case of do while loop, it will be executed at least once. So that test the condition at the end of the loop rather than at the beginning, as demonstrated by the for and while loops. In the case of for and while loops, the condition is checked at the first itself. But in the case of do while loop, the condition is checked at the last, towards the end. So the do while loop construct is something like this: do, then the statements, then while the condition. So the do is happening first. So the statements are executed initially, then we are checking the condition, and if the condition is false, then we move on to the next statement. If the condition is not false or it is true, then it moves on to it again does the statements. So here also the condition can be any valid C expression. The statements can be either a single or a compound, that is a block of code statements. When the program encounter the do while loop, the following events occur. First, the statements are executed, then the condition is evaluated. The statements are first executed, then the condition is evaluated. If the condition is true, the execution returns to step number 1, that is the again the statements are executed. So if it is evaluated to true, the statements are again executed. If it is false, the loop terminates and the next statement is executed. And if this particular condition is false, the loop terminates and the next statement is executed. So this means that the statements in the do while will be executed at least once. So that is the main difference between a while loop as well as do while loop. That is, in the case of while loop, if the condition is false, the statements will not be executed even a single time. But in the case of a do while loop, even if the condition is false, the statements will be executed at least once. So that is the difference between the while loop as well as the do while loop. So in one case, the statements will be executed at least once, and in the other case, the statements may not be executed at all. So, and in all other cases, it is the same. So the do while loop, the flowchart for the do while loop is like this. So first we execute the statements, then we evaluate the condition. Then if the evaluating the condition is false, we exit the do while loop, and if it is true, if the condition is true, we again execute the statements. So that is the do while loop. The statements are always executed at least once. For and while loops evaluate the condition at the start of the loop, so the associated statements are not executed if the condition is initially false. So that is the difference between the while loop as well as the do while loop. So let us see some examples on the while loop as well as do while. While loop we have already seen. Some do while loop. So here, we start with include stdio.h, then into main, then a is variable a is initialized, declared as an integer, and it is initialized to 10. So the variable a is declared as integer, and then it is initialized to 10. So then we start a do while loop, do. So the do while loop is something like this. We have to first give the do, then the statements, then the while condition. So this is it. So initially do, then the statements, then the while condition. That is it. So do, then printf value of a is %d/n a. So the value of a will be printed. then A is incremented by 1, A equal to A plus 1. So this can be written as A plus plus also, no problem, this one. Then this will be repeated till A is less than 20. So let us execute it. See, initially we are checking A is 10, so A is 10 is initially printed. Then A is incremented by 1, then it is checked whether A is less than 21. So since A is not less than 21, then the control goes to this statement, then again the value of A is printed. So 10, 11, 12, etc. Suppose if we check the condition A is less than 10, we are checking the condition A is less than 9. So initially itself the condition is false. So let us see what will happen to this particular situation. So we execute it. So only value of A equal to 10 is printed. So that is at least once this particular loop is executed. At least once this particular loop is executed. So if you want to check the while loop, so we go to the while loop, the n calculate is less than or equal to 12. So we initialize the n calculate as 15. So we initialize the n calculate as 15 and then we check whether this code will be executed or not. See, nothing is displayed. Nothing is displayed because in this while loop, the condition is checked initially itself. The condition is initially checked, but in the do while loop, the execution of the statements is done first, and then the condition is checked. So that is the do while loop. Now let us see some nested do while loop. So inside that nested do while loop, here two integer values are declared, that is I and j. Then I is initialized to 1. Then what we does is we start with a do, then j is set to 1. Then another do, print %dj. The value of j is printed, j plus plus, j is incremented. This is done until j is less than or equal to 10. So it will print j equal to 1 to 10 in a line of code. Then we go to the next line, that is I is incremented by 1. So I is incremented by 1 while I is less than or equal to 10. We check whether I is less than or equal to 10. If I is less than or equal to 10, then again j is set to 1. So as in the previous step, in previous the nested while loop we were discussing, this is a similar situation. But in this situation, the difference is that we are using a do while loop and the values are printed from 1 to 10. 1 to 10 and 10 times it is being printed. So that is the do while loop. So in a do while loop, we have to execute, or the program will execute the lines of code at least once. But in a while loop, it will be it is not necessary to execute it at least once. So now the next thing is the goto keyword. So this is actually not a loop. This can be used as a loop, but this is not actually a loop. The goto statement is one of the unconditional jump or branching. So in the case of looping, actually it is a type of conditional looping. That is, if a particular condition is true, then it is to be, something is to be done or something is to be repeated. In the case of if statements as well as switch case statements, so if and switch case, in that case it is conditional branching. If this particular condition is satisfied, then it is to be done. If this particular condition is to be satisfied, then is satisfied, this particular condition is true, then something else is to be done. So that is the way in which the if condition as well as switch case statements works. But in the case of goto keyword, what does is, whatever be the condition, when a goto keyword is coming up, it goes to the execution. The control of the execution transfers to that particular label where this particular goto statement is pointing to. So that is it. The goto statement is one of a C unconditional jump or branching. So it is branching or jumping statement itself, but it is an unconditional without any condition. Whatever be the condition, if a goto statement is coming up, the what you say, the execution immediately jumps or branches to the location specified by the goto statement. So the statement is unconditional because execution always branches when a goto statement is came across. The branching does not depend on any condition. So a goto statement and its target label must be located in the same function, although they can be in different blocks. That is the only condition that is to be satisfied while using a goto statement. That is, its target label must be located within the same function, although it can be in a different block. That is, it can be in a different block of if condition or in a loop, in a different looping condition. It can be possible, but it should be within that particular function itself. So use goto to transfer execution both into and out of loop. So we can transfer the execution into as well as out of the loop can be done using the goto. But it is not recommended. This goto statement is not recommended. Why? Because we doesn't have a control over the goto statement. Because whenever the goto statement is encountered, the control will be transferred to that particular location it is pointing to. So we cannot keep a record of where from this particular control was transferred or where this execution is coming from. So what we normally do is we avoid the use of goto statements. So let us see how this goto statement is implemented in C programming. So there is a variable A which is initialized as 10. It is an integer variable. It is initialized as 10. So here we give a label. This is a label, loop, then colon. This is a label. A label in the sense this is a label which is to be used with the goto statement. This is to be used with the goto statement. So do something. So we start a do while loop. So do if a equal to 15, a equal to a plus 1, then go to loop. That is actually what it does is a equal to 10, then the condition is a is less than or equal to 20, less than 20. It prints the value of a as we have seen in the do while loop. It prints the value of a from 10 to 20. That is actually from 10 to 19 because a is less than 20. So up to 19 it prints. So what it does is using this loop, if the condition a equal to 15, then it is skip the iteration. That is 15 won't be printed. Then a is incremented by 1, then it goes to loop. If this condition, if this a equal to 15 condition is not given, in that case, whenever this go to loop is coming up, it goes to this loop. So let us execute this one. See, 10, 11, 12, 13, 14, and 15 is missing. 16, 17, 18, 19. So this is how this particular goto statement works. So the goto, since it goes to loop, it doesn't execute these two lines of codes. So if this condition was not present, if a equal to 5, a equal to 15 condition was not there, if it was not there, then obviously this will go to this loop and nothing will happen. Suppose let us comment this particular line, and this one is I am commenting this one also. Then let us see what will be happening if I am completing it, running it. See, nothing will be happening because it is indefinitely go to this loop. So this will be indefinitely going this. If I put this printf statement, suppose if I put this printf statement inside here, print the value of a, so then what will happen? See, the value of a is being incremented indefinitely. This is being incremented indefinitely because go to loop. whatever be the condition, it goes to this particular situation. So that is the situation with that is the condition with the go-to statements. So we normally avoids this go-to statements. Next is a continue keyword. So the continue keyword actually forces the next iteration to take place immediately, skipping any instructions that may follow it. So whenever a continue statement is coming up inside a loop, what it does is it skips any further instructions that is coming below that continue statements. Instead, it transfers its control to the top of the loop. So the continuous statement can only be used inside a loop, inside a for loop or do while loop and while loop, and not inside a switch case selection. Inside a switch case selection, we cannot use a continuous statement, but in the for loop, do while loop as well as while loop, we can use the continuous statement. When executed, it transfers control to the condition, that is the expression part, in a while or do while loop, and to increment the expression in a for loop. So that is it. So in the case of a while loop and a do while loop, if a continue statement is encountered, so then the control is transferred to the expression part or to the condition part. But in the case of a for loop, it is transferred to the increment or incrementing the expression part. So unlike the break statement, the continue does not force the termination of a loop. It merely transfers control to the next iteration. So that is it. In the case of a break statement, if we use a break statement, it terminates the loop. So that we will discuss next, that is the break statement. But the continue statement transfers the control to the next iteration only. But in the case of a break statement, if we use a break statement, it breaks that particular loop. It terminates that particular loop. So this is the flowchart for a continue keyword. So this is a conditional code. Then the condition is being executed. If the condition is true, then the conditional code is being executed. And if there is a continue, then it transfers to condition. If the condition is false, it is terminated. So this is how a continue keyword is being expressed in our flowchart. So the next is a break keyword. So it allows you to jump out of a loop. That is, if you want to terminate a particular loop, if a particular condition satisfies, if you want to terminate that, then this can be used by using the break keyword. So we have seen the break keyword already in the switch case statement. In the switch case statement, in each of the case statements, you have to give the break keyword. So in the loop also you can give the break, but once the break is encountered, it will jump out of that particular loop. So when break is encountered inside any loop, control is immediately transferred to the statement that follows the loop. So that is it. So the break is if the program encounters a break statement inside a loop, the control is immediately transferred to the statement that follows that particular loop. So that is, the loop is terminated. It is usually used along with an if inside a loop. So if a specific condition satisfies, in that case we have to break the loop. So that condition is possible using the break. When the break is inside a nested loop, if the break is inside a nested loop, it can break only the innermost loop inside which it is placed. So if there is a loop inside a nested loop, that is inside a second loop, inside the inner loop, so in that case it will break only the innermost loop inside which the break is coming up. So let us see two examples, an example of continue as well as a break. So here this see, and a for loop is given here. And Anizham, a variable Anizham is defined as integer. Then for Anizham equal to 1, Anizham less than or equal to 10, Anizham plus plus. So that is the value of inum varies from 1 to 10. So in that case, what it is to be done is, it is to be printed. That is, the value of inum is to be displayed on the screen. But if the condition inum equal to 5, if inum equal to 5, we have to continue. So that is inum, that the value of inum equal to 5 will not be displayed on the screen. Let us run it. See, 1, 2, 3, 4. 5 is not displayed here because when inum was 5, there was a statement continue. So because of that continue, it jumped this particular line, this further execution of the codes within the for loop, and then the transfer is controlled to the next incremental operator, that is inum plus plus. So the next line inum becomes 6. So 6, 7, 8, 9, and 10. So this is the way in which the continuous statement works. So here is another continuous statement in which case some other values are again printed, or I mean displayed. If inum plus %2, if inum %2 means the value of remainder by dividing with the 2. If inum is when divided with the 2, if the value is more than 0, if more than 0, it becomes true. So inum %2 means it is the value can be either 1 or 0. If 0 means it is false, I mean yeah, it is false, and if it is true becomes 1 means it is true. So when inum %2 means it is an odd number. When inum is an odd number, inum %2 will return 1. That is, percentage is the symbol for finding out the modulus, the remainder. So in this case, if we execute this one, the odd numbers will be skipped. See, inum %2 equal to 1, so it is skipped. Inum %2 equal to 0, it is summed up, and sum equal to 2. So it actually, what it does is, it sums up all the even integers up to 20 is summed up. So that is another condition. So in this case, for all the odd numbers, the continuous statement is being executed. Now coming to the break statement. So this is an example for a break statement. So a variable a is initialized as integer, that is declared as integer, and it is initialized to 10. So then what we do is, while a is less than 20, we print value of a is printed. So until a is less than 20, the value of a is printed, then a is incremented. But if a is greater than 15, once a is greater than 15, we give a break statement. So what will happen? Let us see. So the value is printed. The value of a is 10, 11, 12, 13, 14, and 15. Only up to 15 it is printed. Why 16 is not printed? Because when a becomes 16, a is greater than 16. So the break statement came out. So the break statement broke the loop, or it terminated the loop. The while loop is terminated. So that is how the value of a becomes only up to 15. So this is the case with a break condition. Then there's let us see the break in a nested loop. So this is a case. So what is happening? Let us see what is being printed. So it prints 3 stars in a row, and but see the for loops. The 2 for loops are given here. The nested for loop for I equal to 0, I less than 5, I plus plus. So initially I equal to I is less than 5. Then j equal to 1, j less than or equal to 10, j plus plus. Since j is less than or equal to 10, actually it has to execute up to 10 times. That is 10 star is to be printed. But here we have given an if statement. If j is greater than 3. If j is greater than 3, it breaks out of this particular loop. It breaks out of this for loop, and a new line character is printed. So the control is transferred to the next line. So that is the way in which this is working. So if we increase this 3 to 5, if we increase that 3 to 5, then see there will be 5 stars printed in a line. 5 stars will be printed in a line. So that is the break statements. Break inside a nested loop will terminate only the innermost loop. The outer loops will be continuing with the execution. And this is flowchart for the condition break statements. If here is the conditional code, and if here is the checking, condition checking. If the condition is true, it goes here. If a break statement is coming up, it doesn't check the condition. Instead, it terminates the loop. So that is the break keyword. So in today's session, we discussed about the while loop, the do while loop, the goto statement, the continue keyword, as well as the break keyword. And with that one, we end the second module.